We can integrate x divided by x plus 1 using u-substitution, but there is a more clever way. Since the numerator and denominator only differ by a constant, that 1, we could add 1 and subtract 1 in the numerator so that we haven't actually changed it at all, we've just added 0, but it's going to allow us to rewrite the integral in a way that's easy to evaluate. So we add 1 and subtract 1 in the numerator. Certainly that hasn't changed anything, but now we can split up the fraction. We can have x plus 1 over x plus 1, and then minus 1 over x plus 1. Splitting that up, we get this, x plus 1 over x plus 1 minus 1 over x plus 1. X plus 1 over x plus 1, of course, is just 1, and then we still just have minus 1 over x plus 1. And this is very easy to integrate. 1 just integrates to x, and 1 over x plus 1 is just the natural log of x plus 1. So we integrate that to get this, x minus the natural log of x plus 1, plus the arbitrary constant. So that's a clever method that doesn't require u-substitution, but we could also use u-substitution if we wanted to. We could let u equal the denominator, x plus 1, and then notice that the numerator, x, must equal u minus 1. du, of course, is equal to dx, and so we end up rewriting the integral in a really similar way to in the previous method. U minus 1 is x, and that's over u, and then we just split it up. U over u is 1, minus 1 over u, and the integral proceeds in a similar way. At the end, we replace u with x plus 1 so that the integral is back in terms of x, and we didn't have this plus 1 in the original answer, but notice we could just wrap that plus 1 up in with the arbitrary constant. So it would totally be acceptable to just get rid of that plus 1 and just say that it's part of the arbitrary constant. Technically, when we wrap the plus 1 up with that arbitrary constant, this c is different from this one. So it's a slight abuse of notation, but it's a pretty common way to do it. Just gather all the constants and call it c. But that's the integral of x over x plus 1. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thanks for watching.